How are you doing today? Let's get started on 4.2, trig functions of acute angles. This lesson is probably a lot of the stuff that you do know about trig, the things that you have learned in your previous classes. So hopefully this one won't be too bad. Let's start off and review from geometry about similar triangles. Triangles are considered similar if their angles are congruent. So if you look at my three triangles, I have a right angle in each one of them. And then my intention is that this angle, I don't know what it might be, maybe it's a 20-degree angle or something. All of these would be 20-degree angles. And then that would mean that this would have to be a 70-degree angle, and all of those are 70-degree angles. If that's the case, these triangles would be considered similar. And not only are those angles congruent, the sides are all proportional. All right, so that's from geometry. That's what it means to have similar triangles. Now, if these were similar, then the corresponding angles are going to be congruent, but also this would have to hold true. The ratio of this side right here to this hypotenuse, that ratio in similar triangles would always be the same. So that ratio would equal the ratio of D to F, and it would equal the ratio of G to I. And I could do that with any set of sides, but because those ratios stay consistent, we've actually assigned names to those different ratios that we can create. Let's look at those. If you have a triangle and you're looking at the ratio of, let's just say, well, and when I pick out these sides, I guess I should specify that you have to have a specific angle that you're referencing. So I'm going to put theta here. Now from this angle, this side over here is considered opposite of that angle. And the leg that it's next to is considered adjacent to that angle. And then of course, since it's a right triangle, we're going to have a hypotenuse. Now that would move around if I switched theta from being to this corner to up to here. Then your opposite and adjacent would swap, but you'd still have the same hypotenuse. Now, looking at this triangle then, if I'm going to pick out two sides to match up, let's say I'm going to pick this side here and this side here. Well, the ratio of this side to this side, we're going to give that a name. We're going to call it the sine of that angle. The ratio of the opposite side to the hypotenuse, we've named that the sine. If I want to look at the ratio of this leg to the hypotenuse, like we did on that previous slide, we were looking at this leg and the hypotenuse, that has a name. That's called the cosine. That's the adjacent to hypotenuse ratio. And the tangent, if you'll recall, is the opposite over the adjacent ratio. These are the trig ratios that you're probably familiar with. You've probably heard of SOHCAHTOA. It's just an acronym to remember these trig ratios. The sine is the opposite over the hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. All right. Let's look at something that might be new. Those are not the only ratios. We also have what we call the reciprocal ratios. If I was looking rather than the opposite to the hypotenuse and I wanted that to be swapped, I'd want the reciprocal of that, we'd call that the cosecant. If I wanted the reciprocal of cosine, if I wanted hypotenuse over adjacent, we would call that the secant of theta. And the cotangent of theta would be the adjacent over the opposite side. These perhaps are new ratios, but all they are is the reciprocal of one that you maybe already know. You do need to know how they match up. You need to recognize that the reciprocal of sine is cosecant. Cosine and secant are reciprocals, tangent and cotangent. I guess these are the easy ones. Tangent, cotangent obviously match up. I always remembered that each one of these has to have a co. Cosine already has it, so it's going to match with secant. Sine does not have a co, so it's going to match with cosecant. I don't know, silly reason, but that's what I always stuck in my head. let's look at a triangle that has some actual numbers on it and see if we can't come up with what these ratios would equal. I've put my right angle down here in the bottom corner, and when you select an angle to put your theta value in, it always has to be one of the acute angles. You can't put theta here at the right angle. It always is the acute angle because if you think about it, if you put it here, the opposite side happens to also be the hypotenuse, and you can't have them both be that. If I look and try to identify what the sine ratio would be for theta, well, that's opposite over hypotenuse, 5/7. If I wanted to find the cosine ratio, well, that would be the adjacent over hypotenuse, and the problem that I have is I don't have the adjacent over here, and typically they're not going to be nice enough to give it to us. It's a right triangle. We can do Pythagorean theorem. We need to start off and do your a squared plus b squared equals c squared. A and b can be either of the legs. C has to be your hypotenuse. I'm going with 5 squared plus b squared equals 7 squared. You take 49 and you minus 25 and you get 24. Square root both sides. B ends up being, let's go ahead and rationalize that as well. 4 goes into that, so 2√6. The adjacent side is going to be 2√6. Now I can do the cosine ratio. It would be the adjacent, 2√6, over the hypotenuse. And then we just kind of go around and do that, but if you look at your tangent for a second, let's see what happens here. The opposite side is 5 over the adjacent is 2√6. We do want to leave these as a radical. You want to leave it exact, but I would like to have that rationalized. If you ever end up with a radical in your denominator, you'll need to take a minute to go ahead and rationalize. That becomes 5√6 over 2 times 6 is 12. And then you look to reduce the 5 and the 12. It does not reduce, so I'm done. When I do my reciprocal identities, I'm really just going to look back over here. I could go down here and do the reciprocal, but I know it's just the reciprocal of what I already have. I'm going to flip it. This is just going to be a 7/5. Cosine is going to be 7 over 2√6, and I rationalize that. 7√6 over 12, it doesn't reduce. And for cotangent, I'm going to do the reciprocal of tangent. But rather than flipping this and then having to rationalize, I'm going to go back to where I began, and I'm just going to flip the original. That way I don't have to re-rationalize it. And I've got it there. That's a typical ACT kind of question where they ask you one of those, knowing basically SOHCAHTOA and knowing what ratio goes with what. Let's try one that's a little bit trickier. I'm not giving you a triangle. I'm just going to tell you one trig ratio. The secant of theta is 2. That's the only one I'm going to give you. Could you figure out what all the rest of them would be? Well, 1 should be easy. I know that secant matches with cosine, and those are reciprocals. Cosine must be 1/2. That's because think of that 2 as 2/1. But that's about all I could for sure have. I said I didn't give you a triangle. It doesn't mean I don't need one. I'm going to go ahead and draw this out. And I don't really care how you draw the triangle. Just make sure it's a right triangle. All this SOHCAHTOA business only works on right triangles. And pick some place to put theta. I don't care. I'm going to stick it down here. But once I put that there, if the secant is 2/1, and that's the reciprocal of cosine. Remember, cosine was adjacent over hypotenuse, so this is hypotenuse over adjacent. Let's fill that in on our triangle. Hypotenuse over adjacent. Now I can do my Pythagorean theorem to find the missing side. 1 squared plus b squared equals 2 squared. 4 minus 1, square root both sides. B is the square root of 3. Now I know the opposite side. Once you know all 3 sides, you get to just start filling in the chart. The sine of theta is opposite over hypotenuse. Tangent of theta would be opposite over adjacent, which is just 1. There's no real reason to write that as a fraction. The reciprocal would be 2 over root 3, but then I have to rationalize 2 root 3 over 3. And cotangent would be 1 over root 3, rationalized is root 3 over 3. Basically just got to know your SOHCAHTOA and maybe do a little bit of Pythagorean theorem. Let's try doing some of these where we do actually approximate. All that previous stuff, we'd like to leave it exact, leave it in radical form. But what if there comes a time when you need to actually get a value for it? Well, we go to our calculator. And this is getting us ready to do something that, solving some triangles and thing that you've probably done. But there's some key things that you have to know about your calculator to be able to use it properly. The first thing that you have to recognize is that there are different modes that your calculator has. Always check your mode and be aware whether or not you are in degree mode or in radian mode. If I'm going to use an angle measurement, it needs to know, is that angle measured as a degree or measured as a radian? Your calculator defaults to radians. Every time we clear our RAM, it goes back to radians. On number 3 here, I need it in degrees. All you do is click mode and go down there and switch it over to degree mode. Once you're in degree mode, then it's as simple as just typing sine 23, press enter, and the sine value is 0.39. It says to round to 2 decimal places. Now on number 4, you'll notice that my tangent does not have a degree symbol. I will assume then that this is in radians. I'm going to go to my mode, switch it back to radians, and then I can do tangent of 3. Notice this answer is a negative 0.14. You will find, and we'll learn more why this happens later on, but sometimes your answer is going to end up negative. Number 5, this one's also in radian mode. That's supposed to be a little fraction. Sometimes that fraction bar doesn't show up for me. 2 pi over 3. I'm just going to press cosine, and then in my calculator, 2, always use the pi button, divide it by 3, and I end up with a negative 0.5. That comes out nice and clean. Not very many of them do. That one does. Let's talk about the reciprocal functions. Cotangent. You don't have a button for cotangent. It's not second tangent. That's not the same thing. We'll talk later about what that does, but cotangent is just the reciprocal of tangent. In this particular example, I have a 2.6 radian measurement. I'm already in radians. To do cotangent, I actually have to do tangent. I will type tangent of 2.6. And I'm looking at my calculator. I have a negative 0.6 there. That was tangent though. I want cotangent. I know it's the reciprocal of that. You actually have a little reciprocal button. And it looks like this. It's x to the negative 1. And it's underneath your math button. And think about a negative 1 exponent really just shifts it to the denominator. It is your reciprocal. It'll flip the fraction or even the decimal. Now I've already done the tangent of the 2.6. All I have to do, I pressed enter and then I press my reciprocal button and it just says do the reciprocal of the answer and I say yep. And I get a negative 1.66. All right, why don't you try the next two and see if you can get those on your calculator. Check my answers, see if you agree. On the number 7, I had to switch back to degree mode, and then I did cosine of 128, then I did the reciprocal button. On number 8, I went back to radian mode, did sine of 11 pi over 7, and then I hit my reciprocal key. Always be aware of what mode your calculator is in. That's probably the biggest thing. If you start getting weird numbers, it might be because you're in the wrong mode. Let's use these trig ratios to actually find some information out. Typically what we'll do is what we say is solve for a particular variable in the triangle. If you look at this example here, number 9, in order to find something, you got to know 3 things. You got to know that you got a right triangle, first of all, and then you're going to need to know 2 other pieces of information. In this case, I have the angle here, and I have the hypotenuse measurement. Now I'm going to go find x. X happens to be opposite of 37. That means I want opposite and I want hypotenuse. You use whatever you're looking for and what you already have. Opposite and hypotenuse is sine. If I set up my ratio, the sine of theta, or in this case 37 degrees, is equal to the opposite over the hypotenuse. All I'm going to have to do is multiply both sides times 8. When I type this in my calculator, I have to be aware of the mode. Make sure you're back into degree mode. Be careful that you don't type sine 37 and then times 8 before you close out your parenthesis. You don't want to do that. That's why I usually do the 8 first here. I'll do 8 sine of 37. And that closing parentheses then is optional. Saves me just a keystroke. I get x equals 4.81, which is a reasonable side length there. Let's try number 10. Now I'm going to edit this, and yours may, or your note sheet might already be edited, but I'm going to switch this. I would like this to be my unknown, and this up here is going to be my 16. Let's see what we would need here. I've been given this angle, got the right angle first of all, that's the first thing. I have this angle here. I know the opposite, and I'm looking for the adjacent. Opposite and adjacent would be tangent. Tangent of a 66-degree angle will always have the ratio of the opposite side over the adjacent side. Now this one is different because the denominator is where my variable is. And that is a little trickier than over here where it was a number. I could just multiply by 8 and I'd have my variable. On this one, I have to multiply both sides by a. Now I'm going to show the work on this, and if you want to do this, show the work because you need to, that's okay. If you can just visualize this process, now what you're going to have to do is divide by the tangent of 66. Sometimes we're going to be multiplying, sometimes we're going to be dividing. It all depends on what's given to you and what you're looking for. I'm going to type in 16 divided by the tangent of 66 degrees. I get 7.12 for that side length. Now let's look at doing that, but we'll do it a little bit more thoroughly. What we're going to do now is solve the triangle for all the missing parts. When we say solve the triangle, it means find whatever you don't know. There's always 3 sides and 3 angles. They're going to give you 3 of those things. We're going to be looking for the other 3. When I look at this triangle on number 11 here, I am in search of angle A. Don't know that. I don't know side B, and I don't know side C. Those are the 3 things missing that I have to find. The first thing I would look for is angle A. Because I know from geometry that the angles have to add up to 180, I can easily subtract from 180 to find that missing angle measurement. And I end up with angle A having to be 48 degrees. To find little b and little c, I'm going to have to do some SOHCAHTOA. Let's start with side B. If I'm looking for side B, I see what that is in reference to the given angle. It appears to be the opposite side, and I know the adjacent. Opposite and adjacent is going to have to be tangent. So I'll set up a little problem. The tangent of my 42-degree angle is going to be equal to opposite over adjacent. Looks like I'm going to have to multiply both sides times 8. Be careful when you type that in. When you hit tangent of 42, make sure you close your parenthesis and then times 8. Looks like we have a little b value of 7.2. Once I know little b, let's do the same thing to find little c. Little c is the hypotenuse, and I'm still going to use what they gave me, the adjacent. Adjacent and hypotenuse would be cosine. Cosine of the 42-degree angle is going to equal the adjacent over the hypotenuse. Looks like I'm going to have to multiply both sides by c this time, which is kind of weird because then I have cosine of 42 times c equals 8. This time I'll have to divide by the cosine of 42. And I get 10.76. I'm going to go ahead and write that up here. 10.7, actually it would round to 7.7. And B was 7.2. All right, that's solving a triangle. Let's try it another way, where I'm giving you some different information. Plus, I didn't bother to draw the triangle for you, so I'm going to make you do that. The thing that you have to remember from geometry is that the opposite side and the angle and side that are opposite of one another have the same letter. Angles are always capital letters. So when I look at my A, B, and C that's given, capital C is equal to 90. That's 90 degrees. This has got to be capital C, which means this is going to be little c over here. Now, the two other legs don't really matter. You just have to make sure you get your hypotenuse in the right place. The other legs are interchangeable. I guess I'm going to make this be little b right here. And if that's little b, that means up here is angle B. I'll make this be little a, so it's 12, which makes that angle A. And then we're going to go through and do some SOHCAHTOA to figure out the missing parts. But what's different on this one is that I don't know any of the acute angles. So I can't do this like where I had the 42 on this example. I don't know those angles. I do know the two sides, and probably the quickest way to find the missing side is just to do a little Pythagorean theorem. Let's go ahead and do that. And that'd be 25 plus 144, and then I'm going to square root that. Okay, I got lucky here. That ended up being coming out nice as 13 for that side length. That doesn't always happen. That's nice. I didn't write up here what we're missing. It looks like we are missing little c, but then we're missing angle A and angle B. Let's start with angle A. The sides that I'm given are opposite and adjacent, so I know I need to use tangent to figure out this angle. When I set it up, I'm going to write the tangent of angle A is equal to opposite over adjacent. And this is new to us to have to find the angle measurement instead of having to find one of the sides. Whenever you're looking for the angle, I'm trying to solve for A, I have to get rid of tangent. Tangent is not being multiplied. Tangent is an operation itself, tangent of A. So to get rid of tangent, I have to do the inverse tangent. And the way that looks, it's like you're doing the inverse tangent of both sides. Inverse tangent. And the tangent and inverse tangent cancel out, and you just have A equals, and that's a little fancier than I'm going to typically show. I'm not going to go and show all that work every time. You just need to know that anytime you're looking for the angle measurement, you're going to have to do inverse tangent to find it. In my calculator, I'm going to type inverse tangent, that's second tangent, of 12/5. Close that parenthesis, and I end up with a 67.38 degree angle. Let's practice that one more time. Now, actually, to be honest with you, I could very easily just, now that I know this 90 and this 67, I could subtract from 180 to get this angle, which would be fine. But I just want to practice that process one more time of finding the angle measurement. This time I'm going to look for angle B. I know opposite and I know adjacent. That's going to be tangent again. Tangent of angle B is equal to opposite over adjacent. In my calculator, I'm just going to type inverse tangent of 5/12. I got B to equal 22.62. And you can always check that and make sure that that adds up to 180, but I think we're good. Let's try one more problem, one where they don't give us a triangle. We're going to kind of try to apply that SOHCAHTOA with some sort of a scenario. On number 12 here, from a point 340 feet from the base of Peachtree Center Plaza, the angle of elevation to the top of the building is 65 degrees. Find the height of the building. Got it. I'm standing over here someplace, looking up at the top of the building. I'm standing away from the base of it. I'm looking for how tall it is. Let's fill in everything we know. We know that we are 340 feet from the base. We know that the angle of elevation looking up is 65 degrees, and we are searching for how tall this building is. I don't need to solve the whole triangle, I just need to find x. Looks like we have the adjacent and we are looking for the opposite. That would be a tangent situation. Tangent of 65 degrees would be equal to your opposite over your adjacent. Multiply both sides times 340. I have a building height of 729.13 feet. Most of this I know is probably review for you. Hopefully you learned something, or maybe you just knew it all, and that's great too. Go work on your 4.2 homework. Good luck.